This is the videos that go along with the guided notes for work problems, okay? So in these problems, what's going to happen is you're going to have either two people, two machines, two things doing the same work, and you're kind of told a little bit about how long it takes each of them separately to do the work or how they can do it together. And you're going to be asked to figure out some information about how long the work takes. Okay, I know that was a mouthful and that didn't make a whole lot of sense. But let's think about it this way. If I can write a whole set of papers math papers in 30 minutes, and let's say Ms. Balzer can do the same set of papers in 40 minutes, how long would it take us if we were grading those papers together? Okay, so you know it's going to go faster if you're working together because you're sharing the work. What we have to know is exactly how much faster we're going. Okay, now there is a formula for this. Okay, our formula looks like this: 1 over t sub 1 times x plus 1 over t sub 2 times x equal to 1. Okay, now I was like, what in the world is all of that? Well, let's talk about what do those variables represent. T sub 1 is the time it takes the first person or machine, could be either, to do the job. Okay? Sometimes it's people working, sometimes it's machines working. Okay? T sub 2 would be the time it takes, that's right there, and that's supposed to be the first person. Here we go, the second person, or machine. Now that's when they're working by themselves. Okay? X is the time it takes working together. Now, the 1 right here in the end, that just means one job completed. Okay? So T sub 1 is how long it would take the first person or machine to do the job. T sub 2 is the time that it would take the second person or machine to do the job. X would be the time it takes them working together to do the job. Okay? Now, we're going to work through 3 examples and see how we can use this formula to help us solve problems. Okay? Now, again, reminder, stop and pause as you need to. Here is example 1. Brad can mow a lawn in 2 hours. Jane can mow the same lawn in 1 hour. How many hours would it take them to mow the lawn if they worked together? Okay? So, let's let T sub 1 be Brad's time, which in this case is 2 hours. Let's let T sub 2 be Jane's time, which is 1 hour. Okay, and X is what we're looking for, because remember, X is for how long it takes them to do the job together, and that's what the question says right here. How long will it take if they work together? So always when we're using a formula, we're going to write that formula down. Okay, now we're going to substitute the numbers we have in the appropriate spot. So we're going to have 1/2 x plus 1 over 1 x equal to 1. Okay, now I need to combine my like terms because we're just going from here solve for x. So we're combining our like terms. So 1/2 x plus, and that's really 1, isn't it? I'm going to make that 3/2 x equal to 1. Okay, because we know that right here, this 1/1 is really the same thing as 2/2. See, I have fractions with the same denominator. So 1/2 plus 2/2 gives me 3/2, 3/2. Now, next step I'm going to do, and I'm just going to squeeze this in here, is I'm going to divide right here. And I can use my calculator, I can use my brain, but I'm going to divide the 1 by the 3/2. Well, we know that that could be, if I'm doing it in my head, that's the same thing as 1 times 2/3 when I take the reciprocal. Okay? And 1 times 2/3 is 2/3. Now, this is an answer that I would not leave as a decimal because it is a repeating decimal. As it's repeating, you cannot get an exact answer as a decimal. You have, for the exact answer, has to stay as a fraction. Okay? So what does that mean? It means it's going to take them 2/3 of an hour working together. That's the meaning of my answer. It'll take 2/3 of an hour working together to mow that yard. Now, example 3 is very similar to example 1, just a different scenario and different numbers. Okay, I want you to think about how we pick out our numbers for our formula. Okay, now, if I go to example 2, example 2 says that Mandy and Karen paint houses. Mandy takes 40 hours to paint a certain house. Karen takes 60 hours to paint a house of similar size. If they work together, how many hours will it take them to paint one house? Okay, so what do I know? I know that T sub 1, I'm going to let be Mandy's time, only because it's the first one they talk about, and that's going to be 40. T sub 2, which would be Karen, and I just made it second because it's the second one they talk about, is 60. Now, I'm going to write down my formula. And next thing I'm going to do is just substitute my numbers in. So I'm going to have 1 over 40x plus 1 over 60 times x equal to 1. Now, combining my like terms, I'm just going to grab my calculator and do this. Okay? If I grab my calculator and I do 1 divided by 40 plus 1 divided by 60, what I'm going to get is 1 over 24x equal to 1. Again, I'm going to do 1 divided by the 1 over 24. If you need to see that, it would be 1 divided by 1 over 24 is what I would just stick into my calculator. And when I do that, it's just going to tell me 24. So x is equal to 24. And what does that mean? It means 24 hours. Okay, so I took Mandy 40 hours to do it, Karen 60 hours to do it. If they work together, it would only take them 24 hours to do it. Okay, go ahead and copy that down, and we'll go to example 3. Now, example 3 is a little bit different. Let's read it together. 2 printing presses, so this time it's not people, it's machines. 2 printing presses running at the same time need 6 hours to print a weekly magazine. Working along the faster press does the job in 8 hours. How many hours are needed for the slower press to do the same job? Okay, so this time I'm being told how long it takes the first machine to do it. I'm being told how long it takes them working together. And I've got to figure out what the second machine is doing, or how long it takes the second machine to do the job. So what I know here is I can let T sub 1 be the speed for my fastest, which is 6 hours. Oh, no, wait. Working alone, the fastest press can go 8 hours. Sorry about that. And working together, the two printing presses working together is going to take 6 hours. Okay? And it says how many hours are needed for the slower one. So what I'm really looking for here is the T sub 2. That's what they're asking me to find. So I'm going to write down my formula. 1 over T sub 1 x plus 1 over T sub 2 x equal to 1. Now I'm going to put my two numbers in their correct appropriate spots. So what I'm going to have right here is 1 over 8 times 6 plus 1 over T sub 2 times 6 equal to 1. Now, if I multiply 1/8 times 6, I'm going to get 3/4. Okay? Plus, now over here, remember, this would be like saying 6 over 1. So if I multiply that, the 1 times 6 is 6. The 1 times 2 sub 2 is just that, equal to 1. Now, I need to subtract the 3/4 from both sides. Okay? So I'm going to have 6 over T sub 2 equal to 1 minus 3/4, which is 1/4. Now, when I look right here, I notice something. This is a proportion. Just like that. And I can cross multiply just like I learned in 7th grade. Okay? So 6 times 4 is 24. 1 times T sub 2 is just T sub 2. Now, that I've solved that for T sub 2, what is that telling me? It tells me it's going to take that second slowest machine 24 hours to do the same job that the fast machine could do in 8 hours, or the two of them together could do in 6 hours. Okay? Now, again, copy your work down, put these notes in your interactive notebook, go to Canvas and find your word problems assignment and complete it, please.